All right, in this module, we're going to be talking about linear inequalities. In particular, today, we're going to learn how to graph linear inequalities. So here are our goals for today. I can understand how to graph the line of a linear inequality. I can understand when the graph has a solid or dashed line. And I know how to determine the correct direction to shade on a graph of a linear inequality. Okay, so if you can remember these clear back from a previous module, we talked about inequality symbols. So remember, if it's less than, the circle on the number line is going to be open. It's going to the left. This means greater than. And it'd be open going to the right. This means less than or equal to, which is closed, going to the left. And this sign is greater than or equal to, and it is closed going to the right. Okay, so that's just kind of a quick review. We've already gone over those ones. So it's going to be kind of similar when it comes to our graphic. Okay, a less than symbol means we're going to have a dashed line, and it's going to go below or to the left of your inequality or of your linear equation. Okay, if you have a greater than sign, that's dashed, and it's going to go above or to the right of your line. Okay, here we have a less than or equal to. Less than or equal to are going to be solid lines, and it's going to be below or to the left of your line is where you're going to shade. Greater than or equal to is a solid line, and that will also be shaded above or to the right of your line. Okay, so let's take a look at a couple examples of how this works. First off, you need to know what the boundary line is. That's the value where the circle goes on the number line. This is the line in the sand between solutions and non-solutions. But instead of a circle, it's actually going to be a line. Okay? Solution set is all the values that make the inequality true. And the shading is the action of marking all solutions on the number line, or in this case, on the entire graph. Okay, so some helpful steps. We're going to plot the boundary line, just like we would when we talked about slope-intercept form. We're going to choose whether the line should be dashed or solid. And then we're going to figure out where we should shade our region. I just really want to point out right here, to always be certain, insert a point not on your line, or we're going to say not on your coordinate. And plug it into your inequality. If the statement is true, you would shade wherever that point is on your graph. If it's not true, you would shade the opposite side of the coordinate of that graph. So let's go ahead and graph some of these. Okay, so the first thing I'm going to do, I notice that I have a y-intercept of 3 and a slope of -1/2. So we're going to start at 3, which would be right here. And the slope of -1/2 would be down 1, right 2. Now you would click on that, and it would create a line on yours. I'm going to go ahead and put a couple more points on mine. Okay, now is it a dashed line or is it a solid line? Well, I'm going to look at this right here. Here it just says less than. It doesn't say less than or equal to. That means I am going to have a dashed line. So if I come back to my line, instead of doing one solid line, I'm just going to do some dashes as I go through this point. Like that. Okay, now where am I going to shade? Once again, it's a less than. So less than will always mean below the graph. So here if I were to create this line, and you think of this would be above the line, this would be below it. Since it's less than, I would shade in absolutely everything below this line. Okay, and if you want to double check, let's see, we got the 0.00 right here. Since it's shaded, it should be true. So is 0 less than or equal to negative half times 0, 0. So 0 less than 3? Yes, it is. So that is the place that should be shaded. Now, when you do your assignment's going to be slightly different because there's a certain feature that it's not on there. I'll show an additional video of how you'll actually be able to do these on the computer on your assignment. But this is how we do it by hand on paper. Okay, 2x minus 4. Y is greater than or equal to 2x minus 4. So I have a slope of negative 4. Sorry, a y-intercept of negative 4. And a slope of 2. So I'm going to start at negative 4. Slope of 2 means up 2, right 1. Up 2, right 1. Up 2, right 1. Okay, is this dashed? Or is it solid? Well, it says greater than or equal to, which means I actually have a solid line. So when I connect these points, it's going to be solid. There's not going to be any dashes in there. Okay, and then where should I shade it? Above or below? So in this graph, slanted up and to the right. So this would be considered above the graph. And this would be considered below the graph. Since it's greater than, that means we got to go above the graph. And I would shade in everything above that. Oops, I shouldn't be right there. My bad. Anything above would be part of my solution. Now let's double check with 0, 0. 0, 0 looks like it is in the range that I think it should be. So is 0 greater than or equal to negative 4? Yes, it is. So I did it correct. Okay, y is less than or equal to negative x plus 1. All right, so I have a y-intercept of 1, slope of negative 1. So y-intercept starts at 1, slope is down 1, right 1, down 1, right 1. That's what negative 1 means. Okay, is it dashed or is it solid? Take a look at the sign. It's less than or equal to, which means it is solid. So I would have a solid line. Now am I going to shade in above or below it? It's less than or equal to. Since we're slanting down to the right, this would be above, this would be below. So I would shade in all of this. Okay, let's double check if 0, 0 is correct. So we got 0 is less than or equal to negative 0 plus 1. So 0 less than or equal to 1? Yes, it is. So we did it correct. Okay, notice on this one, it's a little different. Just they give it to you in a different form. So here, this is standard form. So you could either use the cover-up method, or if you want to convert it into slope-intercept form. I'm going to convert it into slope-intercept form so you see how that works. So basically, I want to get y by itself. So first, I'm going to subtract x on both sides. And I get 2y is greater than negative x plus 4. And I'm going to divide everything by 2. And I get y is greater than or equal to negative 1 divided by 2 is just negative 1/2. And 4 divided by 2 is 2. So there is my equation. If you like to do it that way, great. If not, that's fine. You could just do the cover-up method to figure out the intercepts. Or use the slope, which would be negative a over b. So let's go ahead and graph this. So I have a y-intercept at 2. The slope of negative 1/2, so down 1, right 2, down 1, right 2. This is going to be a dashed line because there's no or equal to. So dashed. And it is going to be shaded above the line because it is a greater than. Once again, you can always check, is 0 plus 0 greater than 4? No, it's not, which means this part should not be shaded, which it's not. So there we shaded and got that correct. Okay? So I understand how to graph the line of a linear inequality. I understand when the graph is a solid or a dashed line. And I know how to determine the correct direction to shade on a graph of the linear inequality. Let me know if you have any questions.